In this video, we will look at how to compute probabilities from information given to us in a two-way table. In this example, we have some data on two different types of sales approaches used to sell cars, an aggressive approach and a passive approach. Data was collected from each approach and on whether or not there was a car purchased or there was not a car purchased. The way the data is presented to us in this table is we can see that a row total in the first row for aggressive approach gives us a total of 580 customers, while in the second row for passive approach there is also 580 customers. So half of the customers had each of these approaches used on them for a total of 1160 customers. Within each row, the data is broken down on whether or not a car was sold or not sold. So for the aggressive approach, there were 270 sales and 310 no sales, while for the passive approach there were 416 sales and 164 no sales, both of them totaling 580. We can also look at this table vertically, looking at column totals. So the column total for the first column is 686, which is the total number of customers that bought a car, combining both approaches. And there were 474 customers who did not buy a car, again combining from both approaches used. These two totals are the same 1160 customers. Computing different types of probabilities, we'll go through some examples below. To start, I would want to calculate the probability that there was a sale. For almost all these calculations we're about to do, you can find the probabilities by using the relative frequencies from the table. You can see here that I have a probability of 686 over 1160. And that is because there are 686 customers who bought a car out of the 1160 total customers. So I'm just using the relative frequency of this event. Similar calculations can be done to find the probability of the aggressive approach being used. If I were to pull a random customer out of the 1160, well, there are 580 who had the aggressive approach used on them. So the relative frequency would be 580 out of 1160. And the similar calculation is done for the passive approach, because there are also 580 people who had the passive approach used on them out of 1160. Everything is simply done by finding a relative frequency from the table. Moving down to the second line, I want to find the probability that a customer had the aggressive approach used on them and bought a car. So I know we went through the multiplication rule last week, but I do not need to use the multiplication rule to find this probability. The way the data is broken down for us in a two-way table is that I can find this relative frequency directly from the table. I simply go to my table and find the cross-section between aggressive approach and sale. And when I find that cross-section, I will see that there are 270 customers who had both the aggressive approach used on them and bought a car. So again, using a relative frequency, the probability would be 270 over 1160. A similar calculation is done for the probability of the aggressive approach being used and no sale. Finding the cross-section of that row, aggressive approach, with the column no sale gives me a total of 310 customers with both traits about them. The 310 out of 1160 would be the relative frequency in this case. Moving down to the third row, I want to calculate the probability that the aggressive approach was used on a customer given there was a sale in the situation. So this line again means given. I'm finding the probability of this first event knowing that the second event did occur. When I am given something, it changes the subset of the population I'm looking at. So since I am given that someone bought a car, I can now narrow my search down to just the 686 people who bought a car. And so to find the probability that the aggressive approach was used on someone, I would use the relative frequency of 270 people who had the aggressive approach used on them out of only 686. Similar over here, when we find the probability of the aggressive approach being used given there was no sale, I again am only looking at the people or the customers who did not buy a car. And that total is 474. So to find the probability the aggressive approach is used, it would only be 310 out of 474. You can see the difference between the calculations on line 3 and on line 2. On line 2, I am not given anything about the customer. I want to calculate the probability that they have both traits. Since I am not given anything about that customer, I can only assume that he or she is one of the 1160. On line 3, I am actually finding the people who had both the aggressive approach used on them and bought a car. But I'm already given one of those pieces of information. So since I know this customer has bought a car, I now no longer think he or she is just one of the 1160, but he or she is one of only 686. So it's the same 270 customers, but the probability is decreased because I already have a known event. Moving down to the fourth line, I want to find the probability of a sale given the aggressive approach was used. This is not the same as what we just did in line 3. While the two traits are the same, this time I am given that the aggressive approach was used. So when narrowing my search, I am now only looking at the first row of 580 customers who had the aggressive approach used on them. While it's the same 270 that have both traits, this time the probability would be 270 out of 580. A similar calculation over here for the probability of no sale given the aggressive approach was used. I am given the aggressive approach is used, I am only looking at the 580 customers in the first row. Out of those 580, 310 did not buy a car, yielding me this relative frequency here. Finally, if I wanted to calculate the probability of the aggressive approach being used on a customer or there was a sale, I'm going to use the addition formula that we had from last week. So what I want to look at is I want to look at all the customers who had one or the other of these two traits. Looking at the aggressive approach, I know that there are 580 customers who had that trait about them. And as far as sales are concerned, there are 686 customers who bought a car. Now if I add up the 580 customers who had the aggressive approach used on them and the 686 who bought a car, what actually happens is I end up double counting the customers who had both aggressive approach used on them and bought a car. This is the probability of A minus B that I need to subtract. The probability of A and B is 270 over 1160. That's the probability that the aggressive approach was used on someone and they bought a car. I subtract off that 270 customers to yield me a result of 996 over 1160. While this calculation down here uses the addition rule, I could have also just used a little logic and relative frequencies from the table. If I'm just adding up all the people that have one of these two traits, aggressive approach or sale, I can note that I would end up adding up 270 plus 416 plus 310. These three boxes right here are the 996 customers that had one of these traits or the other.